excluding 1601 and 1604 because they're a little bit older. The questions are, again, a mix of non-calc and calc. And there's all sorts of different things going on here. So we've got three kind of topic areas: ratio, proportion, and scales. And you'll find that quite often the questions are mixed in. So when you're talking about a scale drawing, you could be talking about proportion. So it kind of mixes with that one. And then when you're talking about ratio, you could also be talking about proportion because as it grows, you've got to split them into different sizes when it comes to ratio. So we've got a few questions to go out. First one is non-calc. I think we go non-calc as well further down. And again, like we've seen, there are some difficult questions out there that are non-calc. It's just a case of finding a way to do them. And it's a space one again, my favorite. Mr. Aldridge wants his students to compare the temperatures of planets. He reads the mean. So when we've got mean, we've added them all up. And we divide it by number of occurrences. So, and he's not kind of done that. It means that over a whole year, over a month, it doesn't matter. So the Mars is minus 65. The ratio of the mean temperature on Mars to the mean temperature on Pluto is 13 to 46. So I'm just going to put 13 here. I'm going to put Pluto here. I'm going to put 46 here. So I've now taken all the information out that I need currently from this question. I don't need to know it's Mr. Aldridge. I don't need to know if it's a year, a month, a week. I just need to know that Mars and Pluto are 13 to 46. That's all I need to know right now. Mr. Aldridge thinks that the mean temperature on Pluto is 275 degrees colder than the mean temperature on Mars. So if we're looking at 275 degrees colder than that, so minus 65 is here, so not, well, not's about here. So we've got we've got another 275 degrees colder than minus 65. So he's saying to us that the temperature on Mars is minus 340. And the way we've done that is we've had minus 65 add 275. Take away, come here. We've added on. What am I going to here now? We've taken away 275. So he thinks it's colder than that. So that equals 340 and a minus. So we're looking for a temperature of minus 340 to say if Mr. Aldridge is correct or not. So the way we're going to do this is we need to split this number into 13 parts because it's saying that 65 represents 13 parts. So if we were going to go into 65 and 13, we could do 13 on the side. It might be easier, mine it. 26, 39, 52, and 65. So because it's non-calc, it's not given us a helping hand, but it's told us that 13 goes at 65 5 times. So each portion is 5. And we've got 13 portions, so that's 65. So we need 46 portions of 5. So 46. So if we put in here, where can we put it out? We'll put in here divided by 13 equals 5. Times by 46. 46 times by 5. Let's have a look. We've got 6 times 5 is 30. 4 times 5 is 20. And our spare 3 is 23. And don't forget, we've got a temperature of minus. Don't forget, it's a minus here because it's basically saying minus 65 divided by 13 will be minus 5, and minus 5 times 46 would keep it as a minus, and so we'd have minus 230. Minus 230. Mr. Aldridge is incorrect. And the way, so when I first did this question, I thought, well, that's a long way out. You know, how's it that? But what I think people might make as the mistake here is they've gone from minus 65 and they've added 275 and it's gone into the plus numbers. It's gone into the plus numbers. So they might have got a number of 210. I think, oh yeah, that's close, but that's not. Or they might have just added those two together and made it into minus 210. So it's important here that when he said it's colder, he thinks it's colder than, it means it's going further away from zero. It's even further, you know, it's even colder than minus 65. So that's why that first part is important to understand that it's actually minus 340. And then we've done the sums. Actually, it's minus 230 on Pluto, not my type of planet. So we've done the ratio here, 45 times minus 46 times minus 5 is minus 230. So Mr. Aldridge is incorrect. A bit hit and miss that one, purely because the mean means nothing. So we don't have to know what the mean is. It just tells us it's the mean. And then we get into the math here when it talks about ratio. So the actual question is about that bit there. That's all you're looking at. So hopefully, I mean, that's 4 marks as well. So that's a big question. A big question where we've only divided by 13. So we've got kind of like the 5 tables going. Then we times by 46. So it's that first bit where I think people have often gone wrong. Okay, Eric wants to mark out a plot for a long jump in one section of the athletics field. The plot needs to be. So this is the question, I think I said last week, where somebody failed this question because they didn't click that button on there. Because when they click that button on there, that disappears and this square grid gets bigger. So what they've done, they've drawn out their grid on here and it's not fit on the screen. So they've just drawn it to the end, which is a bit of a daft mistake because it's 2 marks. So that button there, you click it and it makes the drawing pad bigger. So you'll see why in a minute, because you'll see it don't fit. He wants to mark out a plot of land and he makes the rectangle is 32 meters long. Okay, so 32 meters long and 3 meters wide. Okay, and we've got a scale here of 1 centimeter on the map, or whatever it's called, a drawing, is the same as 200 centimeters in real life. And it says that here. So if we are knowing that 100 centimeters is 1 meter, we can clearly see here that 1 centimeter here and 200 centimeters is actually 2 meters. So we know that 1 centimeter on our little grid represents 2 meters. What he wants is that running track at 32 meters and 3, but he wants it at least 10 meters away from the running track, which will be, if we think 1 centimeter is 2 meters, that'd be 1, 2, 3, 4, 5 squares. So we have to start our running, our long jump pit 5 squares, because that would be 10 meters. And we're going 3 meters up. Each one is 2 meters, so 3 meters will be here. So half of this one, half of them. And when I say you can't fit this on, if you look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So by not pressing that little button here means we're missing those last 2 squares. And it's really important that when you see that little little arrow on your screen, you press it, because it does make this. So that'll be about 15. Let's go there, look. And then that'll be about 16. And so by them just drawing to there, they've missed out on 2 easy marks, because if you think about, you've drawn it to there, that's only 14. So you've not gone to the scale, but you've thought, oh, well, I can't fit any bigger because that's where the page ends. So it can't be any bigger than that. And just by missing that little collapse screen button, they've missed out on 2 marks. So I always think the drawing questions, when it comes to maths, are questions that we all could get right, because it's visual. We don't have to do any maths here. It's just a visual question. We're looking at it and we're doing the drawing. It's just about understanding scale. Okay, so we're going to roll down. That's 2 marks, and we don't have to do anything else. We drag. So I would have clicked on this shape here. It's a rectangle. I'm going to drag it right along. I'm going to press that little button and I carry on dragging so it's here. And that's all you need to do, as long as you've got 5 squares away from there, because it's 10 meters. And we're good. Right, let's scroll down. Olga books holiday. Yeah, nice. So Olga's gone to Spain. Lovely. She hires a car to drive from the airport to the resort. I don't want to drive. It's a bus, right? And I'm always the last drop off. I'm never the first drop off on a holiday. I'll get on the bus. I'm all hot and sweaty. I'm like, it's always the last one. Everybody else is off the bus. Marcus gives her a map showing her the airport and the resort. Olga knows that the scale is 1 to 125,000. The distance along the road between the airport and the resort is, on the map, 51.2 centimeters. She will drive an average speed of 80 kilometers per hour. Work out how long it'll take. So a lot of things to unwrap here. But we've got the scale. You know that 1 centimeter on the map is the same as, let's let it tack in, the same as 125 centimeters in real life. So again, we've got to do what we did above. We've got to convert that into something we're more familiar with. So 100 centimeters is the same as saying 1 meter. So if we divide, and it's a calculator paper, so we can get our calculator. So if we divide that number by 100, and for those of you that are thinking, Steve, just take 2 notes off the end, absolutely, that's how I do it. 125,000, 1, 2, 3. Divide by 100, so we take 2 zeros off the end. We can work it out on our calculator, absolutely we can, but we've just taken 2 zeros off the end. So when we divide a number by 100, the decimal place bounces in twice. So now we're saying 1 centimeter on the map is the same as, I'll miss something, 1,250 meters. I think we can go smaller again, because look, it's in kilometers per hour here. So if we know again that there are 1,000 meters in 1 kilometer, then we can divide this by 1,000. 1, 2, 3. So when we divide by 1,000, we're going to go 1, 2, 3. So then we know on the map for 1 centimeter, we are the same as in real life, 1.25 kilometers. So now we're in a much better position to understand that on the map, how far is that in real life? Okay, because we know that for every 1 centimeter, it's 1.25 kilometers. So 1 centimeter is 1.25 kilometers. So 51.2 centimeters times by 1.25 will give us how far it is in kilometers. So let's work that one out. So we just used we've used the scale we found out here. I mean, had we have times it by 1,250, we'd have got the meters. We'd have still have to convert it somewhere into kilometers to match it to the speed. Unless we go all backwards and we go 80 kilometers per hour is like saying 80,000 meters per hour, and that just gets too complicated. So we would have to have brought it into kilometers per hour and kilometers at some stage. So we did it right at the start, so we can see that each step of the way that we're doing it now shows us we're working in kilometers. Right, where's my calculator? There it is. 51.2, because that's how far it is on the map. We're still talking map here, times by the distance for each centimeter. 1.25 kilometers. So we've now got a distance of 64 kilometers in real life. So what we can do with that, thinking of a triangle, distance, speed, time. As long as D is at the top, doesn't matter which way around I go. I thought the sneeze was coming, but I don't know if it is. So if we want to work out here, look, we've got our distance. We've got our speed. Oh, I'm just putting this. I'm going to write the actual speed. Okay, let's do it. Right, so we've got our speed. And we've then got equals our time. So because distance divided by speed equals time. So if we got our calculator and we've got it here, where's our calculator gone again? 64 divided by 80 equals 0.8. Okay. So it's going to take 0.8 hours. I'm not sure if I would be, as an examiner, if I would be happy if somebody said 0.8 hours. If I said to, I don't know, my mate, oh, by the way, I'll see you in 0.8 hours, they'd be like, what? 0.8 hours? What is that? So to find out what that means in minutes, we're going to simply get the 60 minutes in 1 hour. So we're going to times 60 by 0.8, and that'll tell us how many minutes we're going to get to our resort. Times by 60, 48 minutes. And if you're kind of like quick with your times tables, if you're thinking, right, I know that, if I divide 60 by 10, that's 6, and then 6 times 8 is 48. So yeah, absolutely. But if you were looking at just the numbers we've got in front of us without kind of jumping ahead, we used everything we needed there. So we've got started with the scale. We shrunk the scale down till we found out what it was in real life in relevance to what it was asking us. So it was asking in kilometers, so we worked it out in kilometers. And then we could use our kilometers here to find out how far it was in real life. So it's 64. Then we grabbed the distance, speed, time triangle, took the 2 we needed to find out the third, did the sum, and we've got it might 0.8 hours. It's the right answer. Ultimately, it's the right answer. But for me, I'd like it tidy, but I'm probably the examiner for this one. It's 3 marks. Would they have accepted 0.8? Probably. But I just like, for me, 48 minutes would have been nicer. It doesn't tell me how long it's going to be in minutes. So I presume that 0.8 would have been okay. I just like to tidy things up. Okay, another drawing one. And probably not my favorite one, because I think 3D paper when I was at school wasn't really handed out because, it was probably expensive back then. We didn't really have 3D paper. So on this one, we've got scale again. Map, or we'll put drawing here, is 1 centimeter. And on my real life, it's 10 centimeters. I mean, real life, I suppose it's a case of the actual object rather than real life, but yeah, it's real life to me. So I can see that for every 1 centimeter on here, I need 10 in real life. So when it's 80, so I'm going to put all these measurements here. I've got 80, I've got 90, I've got 60, and I've got 50. So I can clearly see the relationship here is divided by 10 to make it right. It's 10 times bigger. So I've got 8, 9, 6, and 5. That's the hard part. Well, maybe not, because this is a 3D drawing. That's the part where we've done all the scales. We know now all our measurements on this drawing. I'm going to start at the very bottom. Okay, I'm going to start here. Right, 5. This could be good. 1, 2, 3. Okay, 1, 2, 3, 4, 5. Okay, done. 6. Okay, 1, 2, 3, 4, 5, 6. Well, we're getting there. And don't forget, when you're doing it on computer, this line will be making sure it's absolutely straight. 8 on the way up. All right, it's going to be fun. 1, 2, 3, 4, 6, 7, 8. And it's the same for this one and the same for that one. So I'm going to go up from here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now I can do my cross one there. That's my start of my roof. Okay. And I've got one different one here because I can put it in here. Oh, if I do it straight. And I've done everything now I can possibly do without doing one in the middle. It's not actually a line, look, it's just a fake line as such. It's telling me how tall the apex is compared to the other part. So it's 6 along, so I'm going to go 3 along, which will be there. And I have to go 9 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks a bit weird, but it is. It's a 3D drawing, so don't be thinking, oh, that looks really strange. It's meant to. The last few dots always look a bit strange because you've got isometric paper. I'm going to go backwards there. So as much as it's done freehand, it's what it looks like. Okay, I've done that ring. Oh, that's middle bit's incorrect. I've just done that one incorrect. Oh. Okay, I'm sure I have. Did I not? 1, 2, 3, 4, 5. Thought so. Oh, it looked a bit like I've got a squashed roof. Okay, so obviously all lines will be straight. It doesn't say label it. So once you've done your drawing, that's your 2 marks. Quite, well, I'm not saying quite a long 2 marker, but you got to work out your scale first. So to figure out that scale there is the first part for your 1 mark, and then you're getting 1 mark for drawing it, obviously, hopefully neater than that. And there was no need for me to make that box bigger, but had that screen moved along, it's just one big sheet of isometric paper. A 3 marker. Right, a typical hot tub holds 309 gallons of water, all the germs. When it's full, chlorine needs to be added to the water. 250 gallons of water needs 1.5 tablespoons of chlorine. 1 tablespoon of chlorine weighs 14 grams. Okay, so I'm not sure if that middle part is just a bit of information. So let's have a look. How many grams of chlorine are needed for 309 gallons of water? So we're saying here 250 gallons is the same as saying, so we're going to put we'll put tablespoon 1.5. And then we're going to put what we need is grams. So we can see 1 tablespoon equals 14 grams. So if 1.5 tablespoon is going to be half as much of that again. So half, so times 14 by 1.5, and we're going to get 21. So we can see that 250 gallons requires 21 grams of chlorine. How many grams for 309? And so that part, we don't need that anymore. We're not talking tablespoons. We only need this part and this part. So if we were to rewrite that over here again, gallons, we've got 250. Okay, grams, we've got 21. We need the equivalent for 309. So that's the spare number. Okay, so what we're going to do, we're going to go backwards here. We're going to go 21 divided by 250 times by 309. So the way we're going to do it, where's my calculator gone? My calculator is disappearing today. There it is. I think it was 21. 21 divided by 250. That's saying, if you think about it in mathematical terms, if we've got, that's saying literally how many gallons per gram we need. Times by 309. It's given us 25.96. To the nearest gram? No. 25.9. And another way of doing that is, if we look at the relationship here, So if we know how many times that goes into there, so let's do it the other way around. 309 divide, no, other way around it. 250. My brain's now gone wrong on me. Yep, 350 divided by 250. Divided by 250. So we know that it's 1 point. So the multiplier here is, what did I say? 1.236. So to get from that number to that number, we've times it by 1.236. So we do the same direct proportion. We do the same on that side. 1.236. So let's do it. Times by 21 equals 25.9356. So the same answer. It's just looking at where the proportion is. So if you're looking at those two numbers, we look at how much this one's bigger than that one to make this gap the same. Doing it the other way around, it's basically when we've got 4 numbers, we just rearrange them to find the missing number. So it's a bit like algebra, but without the letters. We've got literally 3 numbers to find the missing one. So we did 21 divided by 250 to split it into 250 equal parts. We've split 21 into, so if you think about the fraction there, we've done 21 divided by 250 times by 309. And that's kind of where we've got the new number from. Right, and that's how many grams. It doesn't say to the nearest, which I'm a bit shocked about. But we're going with 25.956 grams because it doesn't say to the nearest whole number, to 2 decimal places. It does say how many grams, but it doesn't say to the nearest number. So I'm happy with 25.956. Good effort if you're going to measure that out. But, right, this one's a bit small. Can we make that a little bit bigger? Maybe we can. Okay, let's make it a bit bigger. Matt joined the cycling club. Oh, another one where we've got a big, and don't forget, it's not all on one exam paper, these. So we have got scales appearing because this topic is all about scales, ratios, and proportion. So this time we've got 1 centimeter. Oh, wrong way around. I'm going to put one. I'm going to put map there. 1 centimeter. Oh no, 1 centimeter on the map is in real life 50,000 centimeters. Okay, so to do this now again, remember what we said before. To get from centimeters, oh, it's not wrong way around now. 100 centimeters. Come on, where's it at? Oh, let me go. 100 centimeters is the same as 1 meter. So we're going to divide 50,000 by 100 to get meters. To divide by 100, we just take off 2 zeros. 1, 2, we bounce the decimal place in 2 places. So we go 1, 2. That means that is 500 meters. And then once we got meters, we know again that 1,000 meters equals 1 kilometer. So if we divide 500 by 1,000, you're thinking, oh, it don't go. Well, it's quite good, isn't it? Because we can then bounce our decimal place from here. We can go 1, 2, 3. So it becomes 1 centimeter is the same as saying on our real life 0.5 kilometers. Because, as you can see, we're talking about 2.5 kilometers. Obviously, if you're aware and you're doing it in your head already that I know 1,000 meters is a kilometer, Steve, so I can just do 2.5 straight away. I know that's 2,500 meters. I can see that it's 500 meters per square, and I'm all right with that because obviously brains work at different speeds. But to break it down into what it's asking for, it's a 2-step. We've divided by 100 to get into meters because there's 100 centimeters in 1 meter, and then we've divided by 1,000 because there are 1,000 meters in 1 kilometer. So we can now go. Naughty elephants, Naughty elephant, squirt water, or never eat shredded wheat. I don't know. You might have different ways of remembering it. You might just know it's north, east, south, and west. But naughty elephants, squirt water, something from school. Again, obviously, remembered it, and so it's doing all right because it's been in the head probably more than 40 years. So we're going to go naughty elephant square. We're going 5 centimeters, 5 squares down, look, because we know that it's 500 meters per square. So 500, 1000, 1500, 2000, 2500. So it's right on there. And where's he going? He's going to cycling club. So we've got cycling club. We've gone south 5 centimeters. No. And that's all that question's asking for. We don't have to draw anything else. Right. Charlie plans a road trip along Route 66 in America. He looks online for flights. Morning flight, afternoon flight, number of seats available, total number of seats. And again, you might have noticed I just read them backwards. I said number of seats available, then total number of seats. I'm thinking fractions already. I'm thinking, you know, this is my pizza slices. It's how big my pizza is. So when I'm talking pizzas, I'm saying that morning flight, my numerator is number of seats available, 338. My denominator is all the flights, all the seats on that plane. Okay. I don't even know what it's asking me to do yet, but I'm just see fractions without kind of thinking, oh yeah, that's a fraction. I'm just thinking I've got to be doing something with fractions because it's given me a fraction without saying this is a fraction. And then the afternoon flight, we have got 396 seats available out of a possible 528. So could we, looking at those on a non-calculator, work it out? We could divide them by 2, divide by 2, divide, get them shrinking so we can look at it. But it's a calculator. So simply, we're going to go top number divided by bottom number is going to give us our decimal. Then we can compare straight away. So we've got 2 sums to do. We're going to go, where's my calculator again? Is it taking its time or is it not coming its time? Okay, it's coming. It's like calling a dog. Right. 338 divided by 416. First decimal, 0.8125. Morning flight, 0.8125. Afternoon flight, same sum, exactly 396. Top number divided by 528. Bottom number, 0.75. Afternoon flight, 0.75. We can directly compare those two now. We can clearly see that the morning flight has a higher proportion of seats available. Morning flight. Let's go, because it's a larger decimal. So we've got morning. Oh, what happened there? Morning flight. Oh, afternoon flight. So he's incorrect. Sorry. Gosh. Move out of the way, move out of the way, move out of the way. Oh, gosh, can't get it. Go now. Incorrect. Incorrect. Is he? Have I done that? Have I set up the wrong way around? 338. Oh, no, yeah, available seats. I'm thinking seats taken. I don't know why. I just had a bit of a moment thinking. So, yeah, there's 333 available seats, not seats that are already booked. Okay, that's fine. So he's incorrect because the morning flight at 0.8125 is the larger piece. Okay. Slow my Charlie. So Charlie travels, and again, if you're thinking, again, we've seen another scale. Well, we're looking at scale again. Charlie travels from the hotel to start of Route 66. The distance he travels is 0.8 meters on the map. So 1 centimeter. Oh, I did it last time. That 1 centimeter on the map. Centimeter is the same in real life as 50,000 centimeters. I know we had 50,000 above, but it was a different exam paper. So we would have to remember or do the sum again. So we know that 100 centimeters is the same as 1 meter, and then 1,000 meters is the same as 1 kilometer. So we're going to divide it by 100. So 50,000 divided by 100. again, we're taking those two off. So equals 500. And then 500 divided by 1,000. Remember, start here, 1, 2, 3. So equals 0.5 kilometers. So it's the same scale as above. So you might have recognized a pattern here because it's two different exam papers, two different questions, but they're using the same scale. So remembering how many centimeters are in a meter, how many kilometers, how many meters are in a kilometer is basic stuff, but you can see once you've remembered it, it's appearing in multiple exams. So it's a case of just applying that scale. It might not be in every exam, so don't be fooled, because we had 125 further up, but generally it's appeared in two exam papers, and we've done them, you know, basically one after the other. Okay, let's scroll down. So he's saying the distance on the map is 0.08 meters. So if I say that 1 meter equals 100 centimeters, if I've got 0.08, what's the centimeters for that? Well, if we look at it from a point of view as if we weren't aware that it's 8, well, we can just go that if I break 1 into half, I know that 0.5 is 50 centimeters. And then I'm going to break this into 5 equal pieces. So I know 0.1 is the same as 10 centimeters. And I've got 0.08. Okay. So when I'm looking at this number, if 1 represents 100, then 0.08 represents 8. I can see that it's 8 pieces out of my 100. So I can break it down like that and see when I get to 0.08 that it's 8. Or I can look at it 1 meter as being like that and see that it's just 8 pieces out of my 100. So it's 8 centimeters. So I know that he's traveled 8 centimeters on my map, not in real life, on his map. So 8 centimeters on his map is the same as what? Well, we know that 1 centimeter was saying 0.5 kilometers because we worked it out here, look. So if we've made that number 8 times bigger, that way, we need to make this number 8 times bigger. So a half times 8 is 4. Is he walking? What is actual distance in meters? Oh, meters. I don't, there's a knock at the door. 1 second, because my daughter won't get it. Right, today's deliveries. We are like an Amazon warehouse. More deliveries. So actually, we've gone too far. I didn't read on. I didn't read on the question there. What is the actual distance in meters? So I've now got to just transfer that back to meters. I know that 1 kilometer is the same as, I mean, we've got 4,000. 1 kilometer is the same as saying 1,000 meters. So 4 kilometers. I've quadrupled that. I've times it by 4. So I need to times that by 4. So I now know that that's 4,000 meters. If any of you spotted that before, you were just testing me, right? To make it go down and then up. So yeah, we went down all the way to meters. Absolutely fine. And as long as, again, you know your conversions, your equivalents, then that's real straightforward. It's only 1 mark as well. So it's not asking you to do all this like I did. It's just a case of knowing, right, what is that on the map? It's 8 centimeters. That represents 8. So I could have gone from there and said that actually that's 400,000. And then once I've got that as centimeters, I can go 400,000. Whoa. Divided by 100 because I want it from centimeters into meters. And then I've got 4,000. But working it out visually, seeing how big it is on the map, what the conversions are. We did it the long way around. But yeah, we could have absolutely, once you know what that, if you could have seen what that is straight away on the map, then that's the only sum you need to do. But we did it both ways. We did good. Okay. And I think this is the last one. Jake is an apprentice at a recruitment agency. The table shows information about applicants last month. 15 successful applicants, and all applicants was 80. A success rate is the proportion of applicants who are successful. Work out the percentage of applicants who are successful. Well, we know if we've got a fraction, we can get it to a decimal by saying top number divided by bottom number. And we know we've got a decimal to get to a percentage. We just times this one by 100. So we can do all that because we have got a fraction right here. We've got a fraction. It says 15 people out of 80 were successful. So 15 divided by 80 gives us our decimal. Times it by 100 will give us our percentage. And for 2 marks, I think that's really, really favourable. Because there's no math to find. It's just a one-step. It's just a one-stop shop there. We've got 15. Oh, not 19. Something getting different else altogether. 15 divided by 80 is your decimal. Times by 100 is your percentage. 18.75. 18.75%. Doesn't say round it up. Doesn't say 2 different places. Leave it at that. And that will be it. So, for the last question of the day, I think we found a relatively easy one. What I would ask is, obviously, we've got a range of topics. I'm going to show you them now. I'm going to open up that bit. So I'll save today's workings out. What I would say is we've had a go at, which one was it? We had a go at numbers and rounding. Numbers and rounding. Let me just double check. Numbers and rounding last. Yeah, I had a one-to-one yesterday where I did collecting and representing data. That was just because that's an exam part that they looked like needed extra practice on. And we did. So online exams, we've done that one. We've done that one. I'm happy to go in order, absolutely. Or if you would say, Steve, I want to have a go at that next because that's where I really don't know, then I'm open to that. But these are all the topics that I would say they don't directly map into Atom, but you'll see these topics on Atom without a doubt. But you'll find that a lot of these questions cross into multiple topics within the exam. So I'm open to suggestions about what you want to have a go next, but if there's no preference, I will keep going in order because I'm a Taurus. I like order. I like logic. So I'm happy to be order and logical. But yeah, unless people want to say, Steve, I need more practice at, and we'll do that. Any questions? All good? All quiet? No questions? Is that good? Silence is good? Is that what silence is?
Very good.
Or?
No questions.
No questions,
Yes,
right?
that's fine.
Yes.
Thank you.
All good?
Yes, all good.
See you later.
All right, bye.
Bye.
See you later. Bye.
Bye.